PhD supervisor saw that the image labeling app, he remarked that this would have given my student 5 months extra to focus on other parts of the workflow rather than just on the labeling images. So we really see how these apps for automatic labeling can be a huge time saver in AI research. Okay, so let's move on to the second step in the workflow, that is AI modeling. So when you're looking at AI modeling, it's really important to have direct access to many algorithms used for classification and prediction, from regression to deep learning to clustering. And we've got a variety of pre-built models as well that you can use, often as a quick starting point or for comparison purposes. And while these algorithms and pre-built models are a good starting point, what we also offer is lots of reference examples. So examples are the way that engineers learn how to use algorithms. And we've got hundreds of examples for building AI models in a wide range of domains. So a great tool set to give you a great foundation for your AI model. We mentioned apps for data preparation and the labeling. We also provide apps for modeling and building, visualizing deep networks, and for help with tasks such as classification and regression. And these apps allow you to abstract away from the coding and allow the student or the researcher to focus on the particular application or problem that they're trying to solve. And another key thing when you think about AI training is that it can take a long time. So often when people think about training AI, they use technologies such as GPUs or FPGAs or cloud services such as AWS. And it's really important to be able to take your model and easily interface in and train your model on these different computing platforms. And to take that single model in MATLAB and be able to use it in multiple places is really key in order to accelerate training. Okay, and then finally on AI modeling, we recognise that the broader AI community is really active and prolific, and they're bringing out new models all the time. And because we support the ONIX standard, your engineers can have access to those new models, but can work with them within the MATLAB environment. So interoperate very nicely with other tools in this area. Okay, so now let's look at system design, the third step. So AI models need to be incorporated into a larger system in order to be useful. Let's consider an example of automated driving. So there's a lot of algorithm work using AI in automated driving around perception systems to be able to accurately identify other vehicles, pedestrians, and understand the environment around the vehicle. But in order for those AI algorithms to be effective, they've got to integrate in with a variety of sensors and with other algorithms for things like path planning and controls, all working together to make sure that the vehicle accelerates, decelerates, brakes and steers perfectly in any situation, in any weather conditions. So these can be accomplished by having an overall system simulation in Simulink that handles not just the AI-based perception algorithm, but the entire vehicle, other vehicles, and many different driving scenarios. So system design is a real key piece of the overall AI workflow. And you can also use simulation to help predict failure states. So here's an example of a wind turbine. You can see a picture here of where there was a failure condition and the wind turbine snapped. Now that's obviously something that you want to avoid happening in reality. So how can you generate data and feel confident that your system is robust to failures? So you can use Simulink and Simscape to model the wind turbine plant and to model the controller, and to use this model to generate synthetic failure data, which this can then be used to train your AI model and help to predict failures before they happen. And then moving on to the last step is one of deployment. So we recognise that AI models are becoming important in a wide range of applications. And many of these applications have different deployment requirements. Some of them, it might be an engine control unit in a production car. It could be an edge system in a chemical plant, an enterprise-based system for production, or a cloud-based streaming system. So AI can reside in any of these kinds of systems. So your AI models need to be able to deploy to any possible platform. And that's what MATLAB and Simulink offer. We've got a unique code generation framework that allows you to take your model that you've developed in MATLAB and Simulink and deploy it anywhere without having to rewrite the original model. Automatic code generation eliminates coding errors and has brought huge value to organizations that have adopted it. Okay, so that completes the 4 steps in an AI workflow. I hope that's given you an appreciation of the strength of MATLAB and Simulink for AI, whether you're working in industry, education, or research. We've looked at how MATLAB and Simulink are a unified and open platform. We've looked at how you can use apps to reduce the time and effort it took pre-processing and labeling data, for example, with the starfish example. We've seen how important AI modeling is within engineering domains and how it's so important to help your engineers add AI as an additional tool in their tool set and can be integrated with their existing knowledge. We've looked a little bit at synthetic data generation with how you can use simulation to generate failure data, as in the case of the wind turbine, to help you with your overall AI-driven system design. And then finally, the importance of deployment, of being able to deploy AI models onto embedded devices, edge devices, enterprise systems, the cloud, as well as onto the desktop. So to summarize, Mathworks is keen to be your AI partner. We offer a great platform that supports a full AI workflow, and we offer expertise to support your AI research and to prepare tomorrow's engineers with the skills and knowledge they need to be successful in industry. So if you're watching this presentation and thinking, how can I get started with this, then do reach out to us. We're keen to help to see how you can integrate AI in your research and use it to help to equip the engineers of tomorrow to go out to get great jobs in industry. Okay, that's the end of my slideshow, so a little bit shorter.
Well, Dr. Tanya, that was really very good. But I think you notched up in highlighting most of the challenges and the artificial role, how it's going to shape up the future of education.
Thank you.
Well, and Mathworks is not new to us. I think even when I was a student, I myself have used this MATLAB for most of things. And today, being the participant mostly in the academia, they will be completely not aware of this Mathworks. So that's really good to hear. Just one question, probably I have a couple of minutes here to take it up. Now in this Mathworks, now considering the academia, the big role of academia using the Mathworks, they've been using for decades. Now, what kind of challenges you foresee now that COVID has taken place, its own position in global, and the academia going more in virtual, witnessing a virtual conference? So what are the different challenges you face and what kind of solutions can be provided in future, especially considering the role of academia?
Okay, so you're thinking about what are some of the challenges in academia with the shift to more virtual and hybrid working? Is that right? Yeah, so that's a great question, and it's one of the things that my team is so involved with. In particular, if you take the education side of things, we're doing a lot of help at the moment to professors around the world who are looking to move their education online. So we've got some great resources for tools such as live scripts or virtual labs, or how you can use technology to really help to engage the students, even if they are remote, but to still get across the key learning objectives that you want students to learn. Yeah, so a great challenge for us. And if anybody who's listening has particular challenges around taking their teaching online, then we'd love to hear from you and be able to help. And I guess from a research point of view, we saw an example in my presentation from some researchers looking to apply AI and deep learning to the challenge of COVID diagnosis using imaging. And that's also something where we're very happy to help academic researchers who may be trying to tackle COVID-19. We're keen to also accelerate their work, which is going to be so important to many of us.
Well, thank you for your response. And how about the coping up of our side compared to the Western countries? Are we on the same side of the coin fighting this COVID, or are we lagging or leading in terms of coping up with the education currently?
Oh, that's great. So how does India compare around the world on this topic?
Yeah.
Oh, that's a great question, and probably my Indian colleagues might be better positioned to answer. I certainly see that the India team, together actually with ICT Academy, has very quickly shifted to delivering lots of webinars and support to educators. And I know that there's been really great attendance and engagement at those webinars. So I would say that I wouldn't necessarily see that I see a big difference as India compared to the world. I think in many cases the challenges being faced by educators are pretty similar. Slightly different timing on term time and things like that, but otherwise a lot of commonality in what we see.
Well, thank you. Thank you, Dr. Tanya Morton, for being with us, for giving your quality insights on your in the role of education industry. Thank you.
I have a question. So can I ask a question, please?
Yeah, please, Professor Mufti. He's one of our keynote speakers.
Yeah, so Dr. Morton, well, thank you very much for the introduction to MATLAB and the things that actually can be done. Well, I have been using MATLAB since 2008 when I started my PhD.
Wonderful.
So, well, I have actually a couple of let's say toolboxes which are developed in MATLAB and they are released in MATLAB. So they are open source for analyzing brain signals. So as a part of my PhD and my postdoc studies that I did over the years, so that is what actually I did. And I actually have been teaching data analysis at Nottingham Trent University in term 1, where I'm teaching the students MATLAB actually. So analyzing data, I mean neuronal signals and medical imaging using MATLAB. And well, needless to say that, well, we for research actually, in my group we actually use a lot MATLAB, and I am somehow biased to MATLAB. So from that perspective, well, I was just wondering that we do have an academic license for MATLAB at Nottingham Trent University. However, I was also thinking that there are certain aspects which actually I think can be addressed if we are co-working, in the sense if we are trying to co-build certain things, like in terms of the research and in terms of the new challenges that we are facing. We think that these are the things which probably would, let's say, be nice to see as features in MATLAB. So if you would be interested in doing that, so maybe in the coming days we can get in touch and probably also have a discussion open on that particular channel.
That would be fantastic. Yes, it's great to hear you getting such great use of MATLAB in your teaching. And yes, if any feature requests or any suggestions for how we can improve the product further, we're always really keen to hear your suggestions. And we have a UK team as well that can help you with some of those. So yes, please pass them along and connect with me.
Okay, great. Thank you very much. Yeah.
Thank you, Dr. Tanya Morton, for your quality time.